In this video, I will create, using the CORMAS Pharo platform, an agent-based model which is used as a benchmark for comparison between different agent-based model platforms. This model is called Stupid Model. It is found in this paper. It is a purely theoretical model without any kind of sense and exists in 16 versions. Also, here we will implement what is necessary to have a minimum viable model to be visualized. So to create a model, we go to the main menu and open the CORMAS interface. We go to File and New, and we write the name of our model, which is obviously stupid, and we hit OK, and it will appear a window to specify metadata like version and author names and emails and model comments, but we hit OK. So to create the entities of this model, we go to the using the CORMAS menu option. We go to programming and the class for each entity. Basically, the agents of this model, which are the social entities, are called bugs, and they exist in a two-dimensional space. Each of these agents at a certain point in time has a location, which is a cell, which is a kind of spatial entity, and they move through the space at each step. Then in CORMAS, we create a class to represent the bugs. We hit the Add button, as this will be an agent, a new kind of agent with a location. We hit here the check button, and we write the name of our agent. It will be just agent. And we hit OK, and as this will be a class with instance, we hit no here. And we also create the spatial entities. So a class for the spatial entities. Here we also leave the default options, and we specify here that this will be a cell class. This will make this simple cell will make here a superclass with a spatial cell behavior. Each cell could have some food available, so we go to with the right button with edit attributes, and a window will appear to specify the attributes of this class. These are the attributes of the superclass, and these are of the target class that we selected. So we add an instance attribute, and we just write food, and we could specify the initial value of the food. We could just write 0.1. Hit OK, and the small hierarchy browser will appear with the methods that has been created for the boilerplate code for this attribute. We could just hit close here, and close, and we could see that the value has been created for this new attribute in this class. So we could close here, and let's decide how we will observe each of these entities. So we create a point of view method on each of them. At this point, we use again the class browser of Pharo. So for the POV of the cell, we could specify that will be a gradient of green on the POV point on the food attribute. So we just answer self POV attribute, which is the food, and with a minimum between 0.1 and 0.3, and a color green. And we could do just close this window, and we could do the same for the agent. We go to the POV setter, and for simplicity, we could just write color blue and Command S to save the method. And now we could close this and check that in the model, in the scheduler, we have already the attributes created, so everything is linked to between the model and the agents and the cells. So now we could write the initial instantiation, the initialization of the scheduler. So here we go to the edit initialization option, and a method init will be created, and we can implement here a 10 by 10 grid using the CORMAS API again. Create grid lines 10 by 10, and the neighborhood type, it will be 4, which means that the cells will be square, and close it, which tell us that the space in this model is toroidal. So that is that the cells on one edge are contiguous to the opposite edge. So here we specify as false, and we also can create the number of agents that we will have in this space. We just can create 5 agents, and which are randomly located. Of stupid agents, and again we could specify the point of view that we are interested to show by default. So display POV, which is the POV method of each of the entities. This is stupid agent again, and display POV of the cell, and we save this method. And now we should define the step of the model. So we could close this window and go to the scheduler and just edit a step, and this will generate a step method that we should complete. And in the step we just could write that we ask randomly to the cells to do one step, and ask random the agents again to do a step. So now we should define the step for this each kind of the entities. So for in the step of the bag of the agent, we could just create a new method which is just a step, and we ask it to move. So we say move and update the food available. So the move, it could be just at this simple agent movement consists of moving randomly to a cell where there is no occupant. So we could just write self randomly walk constrained by no occupant, and we save the method. And the other method that we should define is update food. Here Pharo tells us that there is some missing implementer of this method, and the update food is just saying that the batch where we are located, food is just 0. In the step of the cell, now we should define the step of the cell. We could just write that at each step the food, it could be the food that we already have plus some kind of amount of food available. So we could just say that random float from to 0.9, for example. This will update the amount of food available. We could just write 0 here. And we save this method. Now we are ready to test the method. So we hit the initialize button to set up the method of initialization. We could have multiple ones here, and we hit the step, the control method. Again, we could have many. We don't have proofs so far, so we hit apply, and we will have an empty space and a space with some cells that we cannot see really right now. But if we hit the forward button, we see that they are updated with the amount of food available. So this basically is our stupid model running, and they are updating the food available. So we could just adjust the amount of food available to have a better gradient here, but this is basically how a model could be written from scratch in CORMAS Pharo platform.